Well, here we are. This is the Asteroids and Remote Planets section, part of the BAA. And it's one of the areas of astronomy that you could be doing yourself because there's lots of possibilities depending on what you're interested in. Asteroids, of course, cover all manner of objects, just main belt asteroids. Asteroids are much further away, which are sometimes called dwarf planets, out in the trans-Neptunian belt area, and Pluto is an example of that. As well as just looking at the asteroids, there's more that you can do if you've got a CCD camera. For example, you can take images and measure the brightness of the asteroids or measure the positions. And if you do that, you can send those results up to a professional body and they will take the data that you've got and Bob's your uncle, you've added something, contributed to science in some way. But there's lots of other possibilities. There's a thing called asteroid occultations. Because asteroids move, they're in the solar system moving around, occasionally they'll go in front of a star, block the starlight out, just for a few seconds. But if you were there with a telescope, the time that asteroid just went in front of the star, you'd see the star disappear. You could time so many seconds it was out of view, and it will come back again. Well, if a group of us get together and do that, say in the UK, what we can do is we can actually see the shape of that asteroid, and that technique is called occultation work. And all you need is a telescope and a stopwatch. You could have a CCD camera and do something more elegant, but that's fine. One of the things we like to do when we measure the brightness of asteroids is see what happens in time. The asteroids are all tumbling or rotating, spinning, just like the Earth takes once a day to turn. Well, asteroids sometimes turn very quickly, some of them turn very slowly. And what we'd like to know, certain particular ones, exactly what they're doing. So you can participate in what we call rotational light curve photometry. So there we have astrometry, occultations, and rotational light curves. Those really are the main features, and there's always something new to observe with asteroids. It's not like Jupiter or Mars, which is really there all the time. What happens with asteroids, occasionally some of them are really close to the Earth. Those near-Earth asteroids are particularly interesting because you see them up close. Once they're up close, you can take all your images, do all your measurements, and learn something more. Was it always a lump of rock, or was it a comet that's just now died and become extinct? All these things are possibilities you could do. So if you're interested, just click on the connection, send me a message, arbs@brutastro.org, and I'll be pleased to correspond with you. Thanks for your attention.